Welcome to the video. My name is Pushpinder Gill, and this is going to be my email address where you can send me a valuable feedback. So today let's go ahead and get started on the concept of triangles. Well, this is the first video on triangles. In that I will be completely covering GMAT and GRE and partially covering the CAT concepts which are tested for the triangles in these exams. Now, if you're planning to prepare for GMAT or you're planning to prepare for GRE, this video is enough. All the properties which I discuss in this video are enough for you to cruise through GMAT or GRE triangles questions. Okay, so let's go ahead and get started with the concept. Now understand, geometry has two major parts. The first part is you knowing all the formulas, and the second part is you knowing how to apply them. Well, in this video I will be discussing both the parts, but you need to know the formulas before you can apply them. So you just don't say that, okay, I'm gonna take a question at a time, but you need to know all the formulas, you need to know all the concepts which you will be discussing. So every property that I discuss over here has a lot of importance when it comes to GMAT, GRE or CAT or any standardized test. So whatever property I discuss, you make sure you keep a note of it, because this is all about properties and nothing else. So let's start with the most basic of the properties, that sum of angles in a triangle is 180 degrees and it's a polygon with 3 sides. So I'll be giving you a polygon video as well, wherein we'll be discussing about polygons. So the sum of all angles in a triangle is 180. So this plus this plus this, it's always 180 degrees. So let's talk about some different types of triangles. So I'm just gonna give you in layman's language. The first type of triangle is called acute triangle. Acute triangles are the triangles in which all angles are less than 90 degrees. So acute triangles are the triangles in which all the angles are less than 90 degrees. Those triangles are called acute triangles. Okay, let's talk about different. Now the other type of triangle is obtuse triangle. Now obtuse triangles are the triangles in which one angle is greater than 90 degrees. Only one angle. Understand, two angles can't be greater than 90 degrees because the sum of these angles is equal to 180 degrees. So one angle is greater than 90 degrees. Alright, and the third type of triangle is right angle triangle, in which one angle is equal to 90 degrees. Now a very fascinating fact about right angle triangle is that if I name the sides like this, then AB square plus BC square is equal to AC square. Now this is for a right angle triangle. Okay, now similarly, if you take an acute triangle, then AB square plus BC square would be greater than AC square, would be greater than the biggest side. Similarly for an obtuse triangle, so this is true for an acute triangle. Okay, now similarly for an obtuse triangle, that would be similarly the same thing, is just that this would be less than the AC square. So actually the right angle triangle strikes a right balance between the two small sides and the greater side. Okay, so this is all about these three different types of triangles when we measure them in terms of their sides or in terms of their angles. Then there is one more type of triangle which is called the equilateral triangle. Now equilateral triangle has all three sides equal. So all three sides are equal and all three angles are also equal. Okay, so an equilateral triangle has all three sides equal and all three angles equal. We'll be discussing about this in very detail in the coming within few minutes. So let's just go ahead and see isosceles triangle. So in an isosceles triangle, two angles are equal and two sides are equal. So let's suppose if this is an isosceles triangle, let's suppose these two sides are equal, then these two angles will be equal. Let's suppose if these two sides are equal, then these two angles will be equal. That would be the angles opposite to the sides. Okay, so let's suppose if I take another example, let's say this and this side is equal, that means this angle and this angle would be equal. So sides are equal and two angles are equal. That is called an isosceles triangle. Then they said that there was some symmetry in life. Then came scalene triangle. Scalene triangle has nothing equal. Scalene, there are no angles equal, no sides equal. So you won't be getting much of scalene triangles in your standardized test. Okay, so it's just there too. Now let's go ahead and start with our very first property. The property says that sum of length of any two sides will always be greater than the third side. Let's suppose similarly the difference between the length of any two sides will always be less than the third side. That means what? That means let's suppose if this is a triangle and this is A and this is B and this is C, sum of any two sides will always be greater than third side. That is how a triangle would be made. So sum of any two randomly chosen sides will always be greater than the third side. Okay, this has to be true for all the possibilities. Okay, so your two sides will come here. Let me give you an example. Let's suppose this is like 1 million centimeters and this is 1 centimeter and this is 1 centimeter. Will that ever make a triangle? No, that can never make a triangle because these two sides will never meet. Why is that? Because the sum of these two has to be greater than the third side. Then only a triangle can be made. So whenever you get a question, how many possible triangles can I make out of them, you better make sure that you using this property, that sum of two sides is always greater than the third side. Okay. Similarly, if you pick up this question, now this question is taken from the GMAT prep. So it says that if two sides of the triangle have length 2 and 5, which of the following could be the perimeter of the triangle? So if 9 is the perimeter, one side is 2 and one side is 5, the other side would be 2. Similarly, if 15 is the perimeter, one side is 2 and one side is 5 and the other side would be 8. Similarly, one side is 2 and one side is 5 and the other side would be 12. Now, are these triangles possible or not? Well, sum of any two sides has to be greater than the third side. If I see 2 plus 2 is 4, which is not greater than 5, can't be a triangle. 5 plus 2 is 7, which is not greater than 8, not a triangle. 5 plus 2 is 7, which is not greater than 12, not the answer. That means my answer is that none of them will make a triangle. So it's very important when you say which of the following could be a triangle or which of the following could be the perimeter of the triangle. Make sure you better use that sum of any two sides is always greater than the third side, no matter which two sides you choose. Then only it will be a triangle. Okay, now this is very, very important for GRE students, that side opposite to the greatest angle would be the greatest side and side opposite to the smallest angle would be the smallest side. Or I can even say that the side opposite to the angles opposite to equal sides are equal angles. So let's suppose, let me give you an example. Let's say that this is like this. Now this is like an angle X. Okay, so this is this side. The more I keep making the angle, the more bigger I keep making the angle, the more bigger this side will become. That means the side opposite to the greatest angle, it's always the greatest side. Similarly, if you see a right angle triangle and 90 degrees the greatest angle between these two, and hypotenuse is always opposite to 90 degrees. So fine. Okay, let's go ahead and get to the another property which says that area is equal to half into base into height, and height is perpendicular distance between the base and the vertex opposite to it. Now this might seem to be a very simple property. Almost every one of you watching the video right now would be knowing, oh yeah, I know that area equals to half base into height, but it's very important and very critical to use that when comes the right time. Let me show you one example. Let's suppose he's asking you the ratio of the area of the triangle to the ratio of the area of the rectangle. Now if you can very well observe, now I know that most of you would be thinking that, hey, he hasn't even given me that where is it meeting the rectangle, so how am I sure? Now understand that this triangle and this triangle, which meets in exactly half, have the same area. Why is that? Because they have the same base and they have the same height. That means no matter what the orientation is, this triangle and the triangle covering half the area of the rectangle will have the same area. Similarly, if this is a rectangle, this triangle and this triangle and this triangle, all of them are gonna have the same area because they have the same base and they have the same height. So I hope you understand that. It's very important for you whenever you're comparing the areas of figures, make sure that you compare their bases and compare their heights, especially to GMAT students, because it's very critical in data sufficiency questions. Okay, now let's see this question. Now this question says that what is the area of BEC? So let me just get a red pen. So what is the area of BEC? So he's asking you the area of this triangle. Now if you can very well observe in this question that triangle ADC and triangle BDC have the same area because they share the same base and they share the same height. Now how am I sure that they share the same height? Because these two lines are parallel to each other. That means they both share the same area because they both share the same height and the base. Now if you can very well observe, this DEC is common between ADC and BDC. So I can very well write this as AED plus DEC. I can very well write this as BEC plus ADEC. Okay, so this and this gone. That means if I want to calculate the area of BEC, I just need the area of AED, which second option gives me. Alright, I don't really need this one, so statement B gives me the answer. So let me just take a quick recap. Now as I said, geometry, it's all about you using the right property, using the right property at the right time. Now he was asking me to compare the areas. Now how would I know that I have to actually compare the base and compare the height of both the triangles? It's simple, because whenever you're comparing the areas of two triangles, make sure that you're comparing their bases and you're comparing their heights. Now over here I knew that this area, the triangle ADC and triangle BDC have the same area and they both have DEC in common. That means this triangle and this triangle, they both have the same area, and he's asking me the triangle, the area of this triangle 2, and he's given me the area of the triangle 1, which is pretty much gives me the answer. Right? So I suppose you understood it. Alright, I'm just gonna move on to the next property. Okay, now, yeah, though it's called Heron's formula, I usually call it Hero's formula because he used to be like a hero to me. So area can also be calculated using this expression here. Now S is the semi-perimeter. You add all the three sides and then divide it by 2. That is what is your semi-perimeter, and then to calculate the area you say semi-perimeter into semi-perimeter minus A into semi-perimeter minus B into semi-perimeter minus C and the whole root of it. So that will actually give you the area of any triangle. Suppose you don't know the height, you just know the three sides of the triangle. You can very well use this and calculate the answer, especially for GRE and GMAT students. Especially for GMAT students, in a data sufficiency question, if it asks if you know all the three sides of a triangle, you can very well calculate its area pretty simply. Okay, so I'm going to move on to the next step. The next step is the in radius of a circle. So if you draw a circle inside a triangle, provided it touches all the sides. I haven't. Let me draw it once again. Let's suppose this is a triangle, and if you draw a circle touching all the sides, my handwriting is really bad here. So touching all the sides, like the tangent to all the sides, then the radius of that triangle, of the circle, would be known as in radius. Alright, so the radius of that circle would be known as in radius, and the area of the triangle would be in radius times the semi-perimeter. I'm going to repeat it again. The area of the whole triangle would be the in radius times the semi-perimeter. So I suppose you know how to calculate semi-perimeter. In the previous slide we just did that. Semi-perimeter is nothing but sum of all the sides divided by 2. So I can say that area to be in radius into sum of all the sides divided by 2. Alright, especially for GMAT students in data sufficiency questions, you don't have to actually calculate the area. You just need to know, if you know the in radius and you know all the sides, you can very well calculate the area. And if you know the area, you know the in radius, you know 2 of the sides, you can calculate. So that would be very helpful for you to know that, alright, there is a relationship between a circle inside a triangle touching all the sides and the triangle. Then if you draw a circle outside the triangle in such a way that it touches all its vertices once, then the radius of that circle would be known as the circumradius. Okay, so the radius of the circle would be known as the circumradius, and the area of the triangle would be product of all the sides of the triangle divided by 4 times the circumradius. So the area of the whole triangle would be product of all sides divided by 4 times the circumradius. Okay, so very important property you got to know, especially in the GMAT. Alright, one of my favorite triangles, which is the equilateral triangle. So let's go ahead and try to find some relationships, try to make your life a little bit more easy, because mostly equilateral triangles are the triangles which are tested. So as I said that in an equilateral triangle, all 3 sides are equal and all 3 angles are equal. So if this is side A, that would be side A, and that would be side A. Now if you remember the Heron's formula, where the semi-perimeter was sum of all 3 sides divided by 2, and then when you put that in terms of area, you get semi-perimeter into S minus A, which will be again A by 2, S minus B, and S minus C. Again, the area of an equilateral triangle would be root 3 by 4a square. So if you know the side of an equilateral triangle, you can very well calculate the area of the equilateral triangle. And how did we come to know that? We just used Hero's formula, and just instead of ABC we put AAA. Alright, now if I equate this area to half into base, now what is the base? Base is A, into the height of the equilateral triangle, which would be very much this height over here, the perpendicular distance. Okay, so that will give me the height to be root 3 by 2a. Alright, it seems you must be thinking, like, why do I need to remember this? But you know what, this will help you to step down your calculations by such a large amount that you will be able to calculate things a lot quicker, and you will be able to get an holistic view about the triangles. Now this is a height taken from this vertex, and this is 90 degrees. Alright, and this is a height taken from this vertex, and this is the height taken from this vertex. Now this point over here is the centroid, is the center of the triangle. Now this center cuts the height in two parts. Which are those two parts? It's in 2:1. So if I cut this height in 2:1, the first part, if I cut root 3 by 2a in 2:1, the first part would be root a by root 3, and the second part would be a by 2 root 3. Now you would be asking me, what is the fun of calculating this and calculating this? What is so fun about it? Well, if you draw a circle inside an equilateral triangle touching all the sides, the bottom part would be the in radius, which would be a by 2 root 3. Similarly, if I draw a circle outside the triangle touching all its vertices once, this would be the radius, that would be the circumradius, which would be a by root 3. Coming again, cutting this height in two parts, cutting this height in 2:1. The first part is the in radius and the two part is circumradius. So whenever someone gives you an equilateral triangle and a circle around it, well, I've seen so many questions where students have to actually find the relationship right there in the question. So you don't have to actually find the relationship. You watch this video, that means you know it. Alright, so that would be really helpful in that case. So in case someone asks you the relationship between an equilateral triangle and a circle inside or outside, you can very well get the relationship. The in radius would be a by 2 root 3 and the circumradius would be a by root 3. Now let me take a little quick break. Alright, let's start. So understand this. A few more properties of the equilateral triangles. Among all the triangles that can be formed, equilateral triangle has the maximum area given the perimeter. Alright, so among all the triangles that can be formed given the perimeter, equilateral triangle will have the maximum area, and among all the triangles that can be formed with given area, equilateral triangle will have the least perimeter. Let's suppose I say the area of a triangle is 16 centimeter squares. Alright, the area of the triangle is 16, let's say 16 by root 3 centimeter squares, just to make my life easy. Or let's say 16 root 3 centimeter squares. What is the least perimeter that I can get out of it? So I know that the least perimeter given the area is an equilateral triangle. So I'd say this is equal to root 3 by 4 side square, and I can get the side and I can get the perimeter of the triangle. So whatever properties we are doing, don't forget it, because geometry is all about properties. If you know the property, you can solve the question. If you don't know the property, you can go to the end of the world and you won't find the answer. So there is no other approach in geometry, only properties. Alright, this is what I tell my students. Okay, alright, now let's come down to one of the most important concept is the similarity in the triangles. Now let's suppose these are two triangles. Alright, so how do we know that they're similar? Or let's suppose, how do we know that they're brothers and sisters, you know, with same properties? Now if two triangles have the same sides, or the sides are proportional, proportional as in, you know, it's 2 times or it's 3 times or it's 4 times or 1.5 times. So if all three sides are same or all three sides are proportional, so I can say that the triangles are similar. Similarly, if all three angles are same, well, angles won't be proportional. If all three angles are same, that means that the triangles are similar. Similarly, if two sides are same, an angle between them is same, then again I can say that two triangles are similar. Now let's suppose, let me show you that. Let me show you. Let's suppose this is a triangle. Alright, I'm gonna show you a classic example, and this is equal to this, and this is the line joining the midpoint of both the lines. So I can say that this angle is equal to this angle, this angle is equal to this angle, and they both share this common angle. That means I can say that these two are similar. This triangle ABC and triangle ADE, they both are similar. Now, how do I actually use this similarity to my let's suppose to my benefit? You understood. Okay, fine, these two triangles are similar. What does this use to me? Let's suppose this is angle 60, this is angle 30, and this is angle 90. All right, let's suppose in this is angle 30, this is angle 90, and this is angle 60. Okay, let's suppose this is side A, this is side B, this is side C, this is side D, this is side E, this is side F. Now I know that these two triangles are similar. How do I know that? Because all the three angles are same. Now I can just randomly say, alright, which sides would be similar? It's the side opposite to the same angles. What is opposite to 60 here? B. And what is opposite to 60 here? This is the 60, right? E. Similarly, what is opposite to 90 here? C. And what is opposite to 90 here? D. Similarly, what is opposite to 30 here? A. And what is opposite to 30 here? F. So this is the relationship that will come out of if two triangles are similar. Alright, this is the relationship which will come out when two triangles are similar. And how are you going to find this relationship? First you will establish that, alright, these two triangles are similar based on these three things. And once you've established that these two triangles are similar, then you would find the ratio of similarity. And how are you going to find that? Side opposite to the same angles would be in one particular ratio, and that equality would hold for all the corresponding sides. Alright, now one very important thing, that is that if these are the ratios of sides, what will be the ratios of areas of both the triangles? That would be under root of the ratio of areas. Now why is that? Because area is equal to half base into height. That means what? Area is directly proportional to side square. So whatever the ratio of sides would be, under root of that would be the ratio of areas. That would be equal to the under root of the ratio of areas. So if the sides are in 1:2, areas would be in 1:4. Similarly, if areas are in 1:4, sides will be in 1:2. If sides are in 1:3, areas would be in 1:9. If sides are in 1:6, areas would be in 1:36. So you have to understand that this is one of the most tested property in the GMAT. Make sure that you understand this, that if the sides are in A:B, areas would be in A²/B². And if areas are in A:B, sides would be in under root A by B. Alright? So I hope you've understood the similarity. Now this is what it says. It says that in similar triangles, following identity holds. The ratio of medians is equal to the ratio of heights, is equal to the ratio of circumradii, is equal to the ratio of inradii, is equal to the ratio of angular bisector. That is equal to the ratio of sides. And what is that ratio? It's this ratio. This is the ratio in which the whole triangle is. And the square of this ratio is the ratio of their areas. Now this is a very important concept, because most of the students don't get it. Because in high school, either you get it or you don't get it. So make sure you understand this. And if you have any problem, email me. Alright, so I suppose this is sufficient for you to understand. Alright, let's see a question on this. Okay, so this is a question I got when I was giving one of the tests. So it says that AD is equal to 16 and BD is equal to 4. Let me get a red pen so that it's visible. So AD is equal to 16 and BD is equal to 4. Now calculate the area of ABC. Now if you can see that this is 90 degrees. Now if I see this triangle ABC and triangle DCB. if I see this triangle, there is a 90 degree at C and there is a 90 degrees at D. This is the angle shared by both of them, both of the triangles, that is at B. B is shared by both of them, and whatever is here is equal to here, because that's the third angle left between 90 and X. That will be same. So that means this is the triangle. That means these two triangles are similar. How? Because all three angles are same. Now this is the process that should run to your mind mentally, okay? I don't want you to be writing all this down, so this should run mentally into you. Now understand this. Now we have to actually form the equation. How will we form the equation? By getting the sides corresponding to the same angles. Now I'm gonna go with small by big, okay? Because so that I'm sure that I'm not actually misplacing the ratio. I'm not getting the ratio wrong. So what is opposite to 90 degrees? It's BC, alright? So opposite to 90 degrees is BC. What is opposite to 90 degrees here? That is AB for the big angle, that is 20. And what is opposite to X? Opposite to X for the smaller angle, it's CD, okay? And what is opposite to X for the bigger angle? That is AC. Similarly, what is opposite to Y for the smaller angle? That is 4. And what is opposite to Y for the bigger angle? That is BC. So I just got this equation, and I can see that I have to use this and I have to use this. That means from both of them I can say that BC square is equal to 20 times 4. Okay, that means BC is equal to, I'll say 4 root 5, right? So BC over here, it's equal to 4 root 5. Now if this is 20 and this is 4 root 5, so I'm using Pythagoras theorem here to get AC. So AC would be equal to 400 minus 80 under root. Alright, that will actually give me the value of AC. Now once I have AC, which is the height of the triangle, and I have BC, which is the base of the triangle, that means I know the base, I know the height, that means I will know the area, right? So very, very important for you to know similarity, and very, very important for you to recognize that the question belongs to similarity. It's by making sure that only few of the sides are given, and I can see that some triangles in the given figure are similar. So that's when you should hit your mind and you say, okay, I'm going to use similarity here. And before you use similarity, it's very important for you to come up with this. It's very, very important for you to come up with this equation. And I suppose you've understood this this equation. There is nothing more to it. It's just this that you have to actually understand in this case. Alright, fine. I hope you've understood this. So let's go ahead and move to the next one. Now the next topic that we have is right angle triangles. Okay, so I'm gonna do right angle triangles. So I suppose everyone knows what is a Pythagoras theorem. I'm gonna put it down here. So if this is a right angle triangle and this is the perpendicular, this is the base, and this is the hypotenuse, so I can say that h square is equal to p square plus b square. Okay, I don't want to derive it right here, so I just want to tell you that this is the Pythagoras theorem. Now to keep your life easy, you can actually very well learn these Pythagorean triplets so that your calculations become easy. So 3 square plus 4 square is equal to 5 square. 5 square plus 12 square is equal to 13 square. 7 square plus 24 square is equal to 25 square. So these Pythagorean triplets will help you to keep your life easy, to make your calculations faster, especially even for the GRE students. Even though you guys are allowed a calculator, but understand that calculator is just makes you weak and just makes you slower. Okay, so make sure you learn these Pythagorean triplets and keep your life easy. Now this is, you know what, everyone knows this, but there are two types types of triangles which are mostly tested, and they are rigorously tested in GMAT and GRE and CAT, which is the first type of right angle triangle is an isosceles right angle triangle, in which these two sides are same. Now in this, if I say this is side A, this is side A, this would be A root 2. Okay, if this side is A, this side is A, this side is A root 2. And the next type of right angle triangle is, which is very crucial that you understand, especially for commerce graduates or people who don't have a math background, it's a 30 60 90 triangle, which goes like this. If this is A, this is root 3A, and this is 2A. Yes, we are using trigonometry indirectly here, but this is the only triangle that these are the only two right angle triangles which will be used if you pick up any question of GMAT or GRE triangles. So this is the only right angles triangles which are tested. So whenever you see a 45 degrees written somewhere, or whenever you see a 30 degrees written somewhere, or whenever you see a 60 degrees somewhere, or whenever you see a lot of root 2's or a lot of root 3's in a triangle, what are you going to do? You're going to make sure that you try to make this triangle look like a right angle triangle. Let me show you a question. The question goes like this. Now this is 105 degrees, okay, and this is 30. Let's suppose this over here, it's 30 degrees, all right, and this over here, it's 4 root 2. Now how do I get this side? Let's say A and B and C. Now there is no other way for you to get this question unless you drop a perpendicular here. Now you know that this is 90, this is 30, that means this is 60, that means this is 90, and this whole is 105, and this is 30, that means this would be 45 and this would be 45. Now you understand that this is 4 root 2 and this is 90, 45, 45, that means this is 4 and this is 4, and if this is 4, this is a 90, 30 and 60, that means this is 8. So once you make these two triangles a kind of a standard in your brain, you know what, this is a 90, 45, 45, I gotta use that. This is a 90, 30, 60, I gotta use that. When you make these triangles standard in your brain, that will actually help you to, you know, get the questions a lot faster. And believe me, these are the only two triangles on which the whole GMAT and GRE geometry is based, because you can very well make any figure in terms of triangles, because triangles are the base of any figure, of any regular figure, I would say that. Alright, so you can actually cut any figure into triangles, and these are the only two right angle triangles which are used in GMAT or GRE. Okay, alright, though I would be definitely covering a separate video on circles, but you gotta know this property, because this is the right time for you to understand this property. Whenever I draw a circle outside a right angle triangle, whenever I draw a circle outside a right angle triangle, this hypotenuse will always be the diameter. Okay, very important property. If you know that, very good, claps to you, throw yourself a party. But if you don't know it, whenever you draw a circle outside a right angle triangle, this is always the diameter. Now why is that? Remember this property, that if this is theta by 2, so this is 180 at the center, this will always be 90 degrees. So let's suppose I say that this is a circle and this is the diameter. So no matter what triangle you make here, that will always be a right angle triangle. No matter what triangle you make, always it will be a right angle triangle. So again, I'm repeating that whenever you draw a circle taking diameter as the hypotenuse, or whenever you draw a circle outside the right angle triangle, the hypotenuse will always be the diameter. Alright? Okay, alright. Now again, I call it iso-right. Iso-right means isosceles right angle triangle. So let's suppose this is a right angle triangle. Alright. Now you get a lot of tough questions on this. And this is equal to this, by the way. And this is a circle. Alright. Alright. So we have to find the relationship between the radius of the circle and the side of the right angle triangle. Now I very well know that this is A, and this is A root 2. Alright. Now from here to here it's R, and if this is R and this is R, this would be R root 2. I suppose you know that. That's the circle of a property of a square. Because this is 90 degrees, this is R and this is R, this would be R root 2. So this from here to here, understand that. This is again 90 degrees, this is again 45. Now I'm gonna draw this triangle once again. It goes like this. If you see, this is the 90 degrees and the perpendicular is R plus root 2R. Okay? And the hypotenuse is A. Now I can very well get the relationship between this because this is again an isosceles rat. Alright, so by this I can say that root 2 into R plus root 2R, that is equal to the A, that is equal to the side. So this is the relationship between isosceles right angle triangle and the circle inside it. Now I don't want you to learn that. Believe me, I don't want you to learn that. I just want you to understand the way which I got this answer, because it's very important for you to know the process of getting the answer. Alright, so what I did here was this was R and this was also R, so this was R root 2 and this is already R. And if I see this triangle, this triangle, if I see this triangle, this is R plus root 2R, this is A, that means this into root 2, it's actually equal to the hypotenuse. This is again an isosceles right angle triangle. Alright, so that means this is the relationship between an isosceles right angle triangle and a circle inside it. So I suppose you've understood this. Let's move forward. Okay, few points that will help you to make your calculations faster. Alright, in a right angle triangle, the midpoint of the hypotenuse is equidistant from all three polygon vertices. So if let's suppose this is a right angle triangle, the midpoint of the hypotenuse, it's actually as far as from here, as far from here, and as far from here as well. Now we can very well say that, because if you see again, similarity follows, because if this is half of this, this would be half of this again, because this and this would be same. Alright? Alright, so this is the property of a right angle triangle. The next property is that right angle triangle with the given hypotenuse has the largest area when it's an isosceles right angle triangle. So an isorat will have the largest area given the perimeter and given that it is a right angle triangle. Alright, so usually an equilateral triangle has the largest area, but if let's suppose it says that okay, it's a right angle triangle, then an isosceles right angle triangle will have the largest area. Will help you to solve most of the very tricky questions. Okay, alright, so I suppose you understood. There's no understanding here. It's a property. You gotta learn that it's a property. Alright. Okay, let's talk about median. Now, few points which are very, very important in median is that median is the line drawn from one of the vertex which actually divides the other line in two equal parts. Actually, it divides it into two equal areas as well. The area of this triangle will always be equal to the area of this triangle. I know, guys, there is a question running in your mind. I'm going to solve that question. Let's suppose this is the triangle, then the median will run something like this, so that these both are equal, and the area of this figure will always be equal to the area of this figure. And the point where all the medians meet is known as centroid, and I think we already discussed this, cut this in two ratio 1. Alright, not that important, guys. I would say out of a scale of 5, this is like this holds like an importance of 2, but you need to know this. You need to have an exhaustive view of triangles, so that's why I've put it here. Okay, so median is which divides a triangle in two parts of equal area, centroid where all the medians meet, and centroid divides each median into ratio 1, just the way you saw in an equilateral triangle. Alright, let's go ahead and do some questions so that I show you how these properties are important. As I said, you're gonna know, you just need to know just these properties. Now, let's see. Now this question says that this is a figure here, alright? So this is something like this, and it says that the star consists of how many? It consists of these triangles, and they all are equilateral triangles, okay? So I'm gonna draw like this. They all are equilateral triangles with side 4. And what is the area of the entire star? Now, as I said, everything can be divided into triangles. So divide this into triangles. So this and this and this and this and this. So this actually makes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So this actually makes 12 triangles of equal area. And what is the area of the triangle with side 4? Root 3 by 4 into side square times the number of triangles. That will actually give you the area of the whole star. Now the point of 6-sided star consists of 6 identical equilateral triangles. So I'm going to show you on that figure as well. So this triangle and 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 this triangle, these 6 triangles, okay, 1, 2, 3, 4, 5, 6. These 6 triangles have the equal area, and if I actually join these two, and if I join this, and if I join this also have the same area, and these also have the same sides. So it actually makes it to be 12 same triangles with equal area. So I just find the area of one triangle, multiply by 12. I suppose everyone understood this. Let's move forward to the next question. Now it says that I'm going to read out the question to you. Now it's very, very important for you to draw the figure, guys. Always make sure you draw the figure. Now, triangle ABC is inscribed in a circle. Alright, good. Good, you've inscribed it in a circle. Now such that AC is the diameter. Now if this is the diameter and this is a triangle, which property is that? This is always 90 degrees, isn't it? Now if this is 15 and this is 8, what will this be? That would be equal to, come on, tell me, that would be equal to 12 or 13. So you just need to know Pythagorean triplets. Well, this is 15 and this is 18, so this would be 17 because this is the hypotenuse. You can very well confirm 225 plus 64, that will actually give you 289, and under root of that would be 17. So this is 17, and what is the circumference of the circle? Very well, it's 17 pi, right? Which is 2 pi r or pi d. So you know, you didn't need to have to actually do anything in the question. You just need to know that if you make any triangle with diameter as the hypotenuse, then always it will make a 90 degrees at the other side. Alright, just few more questions left, and let's see this question. Now in this figure above, what is the value of x? Now if this is 3, this is 4, this is 90 degrees, that means this is 5. If this is 13, this is 12, and this is 90 degrees, this is again 5. How do I know that? Well, I remember some Pythagorean triplets. If this is 5 and this is 5, that means if this is 55, this is also 55. And if this is 55 and this is 55, so x is going to be 70. How tough is it? It's not at all tough. And this is like a GMAT level question. So you got to sail through these questions, because these questions should, build your confidence, get you time, and make sure that you get a 51 in the GMAT. Alright, fine. Let's see this question. Now, if BD is equal to CD, what is the value of x plus y? Now, I just need to know the value of x plus y. Now, if this is V, this is going to be 180 minus V, isn't it? Because the sum of angles in a straight line is always 180 degrees. Similarly, x plus y plus 180 minus v is equal to 180, or I can say that x plus y is equal to v. Well, this is again a property that this exterior angle is equal to sum of these two interior angles. I forgot to mention that. So these exterior angles is equal to sum of these two interior angles. So I just need to know the value of v. I would very well get the value of x plus y. Well, you know what? This pretty much gives me the value of v. But if I see the second statement as well, it says that BD is equal to CD. That means this side is equal to this side. That means V is equal to U. And if I know the value of W, I would be able to calculate the value of V pretty easily, isn't it? Similarly, I'm going to show you here. If this is equal to this, and from the first statement it gives me 32 degrees here. So what will I get V to be as? 2V plus 32 is equal to 180 degrees, and from here I'll get V to be 74, isn't it? Now this is giving me V to be 74. Once I have V to be 74, again the statement would be sufficient, and hence D will be my answer. Are you seeing that, guys? If D is your answer, both the options are giving you the same answer. Understand that, GMAT students. If D is the answer, make sure you verify that both the statements are actually giving you the same answer. Okay? Alright, let's move on to the next slide. So thank you very much for watching this video, and this is going to be my Facebook page where you can visit and make sure that you go there and get some questions every day. So this is going to be my email address where you can send me your valuable feedback, and this is my name, Pushpinder Gill. So thank you very much, and see you next video.